the stream. This is your hack and nickel web Cyan. Welcome. I tried to adjust the mic today because I saw the noise filter is eating up some of my voices last stream. Can you hear my cat? My cat has been complaining about stuff. Ow, ow, ow. Good morning. Good morning. Welcome Dan, welcome Paul, welcome Ransan, welcome 冰喵，欢迎 welcome Batomi, welcome Burning Star, long time no see. How are you? How are you? Welcome Sebastian, welcome Stuffy, welcome Muhammad. おはよう皆さん。今日ね、we are learning packages, crates, and modules in Rust. Last time, we learned about structs, defining structs, using structs, method syntax, associated functions, and then we learned about how to define your own type with enums and use pattern matching. So today, moving on, we are learning how to manage our projects with packages, crates, and modules. Welcome Lloyd, good morning. Okay, let's get started. This is a long introduction for the chapter. As you write large programs, organizing your code will be important because keeping track of your entire program in your head will be impossible. By grouping related functionality and separating code with distinct features, you will clarify where to find code that implements a particular feature and where to go change how a feature works. So this is talk about we need to organize our code, put features and related functionality together, so it's easier to find them. 海芙妮呀，早上好，欢迎。The program we have written so far have been one module in one file. As project grows, you can organize code by splitting it into multiple modules and then multiple files. A package can contain multiple binary crates and optionally one binary crate. So just like other programming language, you can split code into multiple modules and import the module. A package can contain multiple binary crates and optionally one library crate. Ooh. As package grows, you can extract parts into separate crates that become external dependencies. This chapter covers all these techniques for very large projects of a set of interrelated packages that evolve together. Cargo provides workspaces, which we will cover in Cargo Workspaces section in chapter 14. So we are not yet talking about workspaces in Cargo, but we will be separating parts that become external dependencies. 最近直播时间越来越早了，对，稍微改了一下直播的时间。In addition to grouping functionality, encapsulating implementation details let you reuse code at higher level. Once you have implemented an operation, other code can call that code via the code's public interface without knowing how the implementation works. Also, this is encapsulating. Cool. The way you write code defines which parts are public for other code to use and which parts are private implementation details that you reserve the right to change. This is another way to limit the amount of detail you have to keep in your head. So besides grouping functionality, we're encapsulating implementation details. So when the other code the public interface, it doesn't need to know the implementation. So it's clean. This is a clean code. 有没有找开头的找？いいね。A related concept is scope. The nested context in which code is written has a set of names that are defined as in scope. When reading, writing, and compiling code, programmers and compilers need to know whether a particular name at a particular spot refers to a variable, function, struct, enum, module constant, or other item and what that item means. You can create scopes and change which names are in or out of scope. You can't have two items with the same name in the same scope. Tools are available to resolve name conflicts. So there's also something to do with scope that we can manipulate. Cool. Rust has a number of features that allow you to manage your code's organization, including which details are exposed, which details are private, and what names are in scope in your programs. These features, sometimes collectively referred as the module system, include packages, a cargo feature that lets you build, test, and share crate. Ooh. And crate, a tree of modules that produce a library or executable. Modules and use let you control the organization, scope, and privacy of paths. Path, a way of naming an item such as struct, function, or module. So we have packages, which is a cargo feature, and crates that produce a library or executable. Modules and use let you control organization, scope, and the privacy of the path. And path is a way of naming an item. In this chapter, we will cover all these features, discuss how they interact, and explain how to use them to manage scope. By the end, you should have a solid understanding of module system and be able to work with scopes like a pro. Okay, let's get started. How does all this happen together? Packages and crates. The first part of module system will cover our packages and crates. A crate is a binary or library. The crate root is a source file that the Rust compiler starts from and make up the root module of your crate. So we have something called crate root. It's a source file. And Rust compiler starts from there and makes the root module of my crate. A package is one or more crates that provides a set of functionality. A package contains a cargo.toml file that describes how to build those crates. Several rules determine what a package can contain. A package can contain at most one library crate. Okay, so a package which is one or more crates can contain at most one library crate. It can contain as many binary crates as you'd like, but it must contain at least one crate, either library or binary. So a package can contain at most one library crate, but it needs to contain at least one crate. So many rules. Let's walk through what happens when we create a package. First, enter the command cargo new. So we are creating a new project. Cargo new my project. Okay? And when we ls my project, it shows the cargo.toml. And if I look at my project source, it shows the main function, the main file. When we enter the command, cargo created a cargo.toml file, giving us a package. Oh, okay. New my project, cargo.tom. Here. So we have a package named my project with version and edition, and it shows dependencies. And the main file, main.rust, is the crate root of the binary crate, with the same name as the package. With the same name as the packet? Oh, it's the crate root of a binary crate. The name is my project. Okay. Likewise, Cargo knows that if a package directly contains source lib.rust, the package contains a library crate with the same name as the package. So, what does this mean? Looks like some intro. It's talking about packages. So, if Cargo knows it has this file, this lib.rs, the package contains a library crate with the same name as the package. And the library is its crate root. Okay? Cargo passes the crate root files to Ascii to build the library or the binary. So Cargo will use the crate root to build the binary in Rust compiler. Here we have a package that only contains main.rust, meaning it only contains a binary crate named my project. If a package contains main.rs and lib.rs, it has two crates, a library and a binary, both with the same name as the package. A package can have multiple binary crates by placing files in the source bin directory. Do you have it? We don't have it. We don't have it in this. Each file will be a separate binary crate. A crate will group related functionality together in a scope, so the functionality is easy to share between multiple projects. For example, the rand we create in Chapter 2 provides functionality that generates random numbers. We can use that functionality in our own project by bringing the rand crate to our project scope. All the functionality provided by the rand crate is accessible through the crate's name rand. Okay, so we can use the rand. Yeah, we can create a package. I think we should be creating some package with this example, right? With some example that probably will come later. We have like 5 sections for this chapter. It's a long chapter. Keeping a crate's functionality in its own scope clarifies whether a particular functionality is defining our crate or the rand crate and prevents potential conflicts. It keeps mentioning we should keep things organized. We want to keep a crate's functionality in its own scope. Either in our crate or in the external crate, and this is going to prevent potential conflicts. For example, the rand crate provides a trait named RNG, random number generator. We can also define a struct named RNG in our own crate, because a crate's functionality is namespaced into its own scope. When we add rand as a dependency, the compiler isn't confused about the name RNG it refers to. In our crate, it refers to the struct RNG that we defined. We would access the RNG trait from the rand crate as the rand bonbon RNG. So this is the name scope of the rand crate. So it's okay to use the same name as long as the scope is different. いいね. I think just like in C++, this namespace shorthand. Let's move on and talk about the module system. Defining modules to control scope and piracy. In this section, we'll talk about modules and other parts of the module system, namely paths that allows you to name items, the use keyword that brings a path into scope, and the pub keyword makes item public. Also, this is about public and private. Hello Tita, welcome! We also discussed the as keyword, external packages, and the globe operator. For now, let's focus on modules. 欢迎 Lily。怎么就逮捕了？有没有犯错？Lily 是世界警察吗？Okay. So we are talking about paths. And we use the use keyword to bring a path into scope. Use the pub keyword to make items public. Modules let us organize code within a crate into groups for readability and easy use. Modules also control privacy of items, which is whether an item can be used by outside code or is an internal implementation detail and not available for outside use. So module organize code within crate, and we can control the privacy of the code by using public or private. As an example, let's write a library crate that provides functionality of a restaurant. Let's write a restaurant. We'll define the signatures of functions but leave their bodies empty to concentrate on the organization of code, rather than actually implement a restaurant in code. In the restaurant industry, some parts of restaurant are referred to as front of house, and others as back of the house. Front of house is where customers are. This is where host seats customer. Servers take orders and payment, and bartenders make drinks. Back of house is where the chefs and cooks work in the kitchen, dishwashers clean up, and managers do administrative work. To structure our crate in the same way that a real restaurant works, we can organize the functions into nested module. Oh, we are creating nested module. Create a new library named restaurant by running cargo new library restaurant. Then put the code into the library source to define some modules and function signature. Okay, finally we're getting into some examples. Finally. So let's do cargo new library. Restaurant. Yeah. And we have a source. Where's restaurant? It's here. This is our restaurant, and in the source we have the library. a test. Let me just copy the entire thing over. Okay. I would also like Rust by example. I checked it out yesterday. I was like, why didn't I do that? But I also like reading lots of text. The reason I want to learn Rust is like I wanna learn a language that like I can understand it in details. So I like the text explanations. Okay. So for module we put mode keyword at the front. And there's a mode hosting. The two functions add to waitlist. Welcome, author. Brazil? Brazil? Wait, what's that? What? Brazil? What is that? Is it a span? Brazil. Oh. Hola. You will learn a language that is proportionally many cute fanboys use. Yes. Yes, I heard it's famous. Function. Sit at table. Defiance, welcome. Hello. How are you doing? Long time no see. Mod serving. Function take order. Function serve order. Function take payment. Boom, boom. So we define the module by starting with the mode keyword and specify the name of the module. Front of house. Lowercase. And put curly brackets around the body of the module. Inside modules, we can have other modules, and in this case we have hosting and serving. Modules can hold definitions for other items such as structs, enums, constants, traits, or functions. By using modules, we can group related definitions together and name why they are related. Programmers use this code would have an easier time finding the definition they wanted to use because they can navigate the code based on groups rather than having to read through all the definitions. Programmers adding new functionality to this code would know where to place the code to keep the program organized. In it, that's why we organize them into modules. I was almost late to science in this learning stream. Hello Christopher, good morning. Welcome. I feel the chat is my sensei. Chat is my TA. Blake, hello. Hi Cyan, I'm not a programmer but I like this Rust stream. Thank you. What do you enjoy? Do you plan to code in Rust? Or is it just fun to see some new stuff? You've been doing well? Nice to hear. Nice to hear. Server order? So what is a server order? server order. What's a server order? What is a server order? Can we order a server? That's so cute. Def is more like a function in Rust. Mod is a module. Yes. Thank you. Monetic Cat, thank you, Julio. So we have a tree, we have a crate, and then we have the module front of house. We have hosting and serving as the modules, and we have functions in them. This tree shows how some of the module nest inside one another. For example, hosting nests inside front of house. The tree also shows that some modules are sibling to each other. So hosting and serving are sibling because they have the same parent. The module tree might remind you of the file system directory tree. This is very apt. What's apt? Comparison. Just like directories in a file system, you use modules to organize your code. And just like files in a directory, we need a way to find our modules. Okay. Neatly organized. Will you guys write large Rust project? Do you guys use a lot of modules like this? Mod is like a new file in Python. It's like namespace in C++. Ooh. Thank you, John. Welcome. I already made one Neko made copy in Minecraft. I did. You remember everything. This tutorial doesn't skip fundamentals like other tutorial. Yeah, it's very clear. It's very clear and focus on the fundamentals. Importing module since file is module in Rust. Apt means good or appropriate or something like that. Oh, okay. So it's a very appropriate comparison to a file system. Modules are definitely used. I use inline modules sometimes, but bigger things get their own files. Ooh. Modules are great, but usually each module is in its own file. So you just use them in other file. You don't need to check extensively on the implementation. Encapsulation! Very nice. Pass for referring to an item in module tree. To show Rust where to find an item in module tree, we use pass in the same way we use pass when navigating a file system. If you want to call a function where it needs to know its pass. Oh, that's why we were looking at that tree. A pass can take two forms. An absolute pass. An absolute pass starts from a crate root by using a crate name or a literal crate. Literal crate? A relative pass starts from current module and uses self, super, or an identifier in the current module. Okay? Hello Mario, welcome. In my small project, I have about 6 to 7 crates, and every crate has about 2 or 3 modules. Ooh. So interconnected. Both absolute and relative paths are followed by one or more identifiers, separated by double columns. Double columns. So paths will be followed by double columns. Let's return to the example. How do we call the add to waitlist function? Add to waitlist function. So we use if we use an absolute parse, or we use a relative parse, it will be like self.hosting column Iterators. No, I'm just guessing. I'm just guessing. Okay. So there are two ways to call this function from a new function, eat at a restaurant, defined in crate root. The eat at a restaurant function is part of our library's crate's public API, so we mark it with the pub keyword. In the exposing path with the pub keyword sections, we'll go into more details about pub. Note that this example won't compile just yet. Okay. So we will be adding a public function, eat at restaurant. So this is absolute parse because it used the literal crate, and we use front of house. Oh, it's not that. It is all columns. Posting column. Add to wait list. Boom. Are you lagging? You're on the train. Are you going back to home? なるほどね。なるほどね。I see. Doesn't なるほど at all. That's me. Please enjoy the stream. I'll see you in archive. Thank you, Blake. Enjoy whatever you do. Literal crate means the word crate itself, which refers to the root, which refers to root of the current state. It's a keyword similar to self or super, which refers to current module or its parent. Oh, so this is the root of the current crate. So we can use the double column to find each module. Good night, Ice Cat. 晚安，早点睡哦。You should install Rust Analyzer extension for VS Code. It's bad epic. How do I install that? Rust Analyzer extension for VS Code. Install. Would it restart? Oh. Install. Oh. できた. What does it do? What does it do? Is it active? Oh, what? It shows all the stuff? So cool. What? This is the Rust Analyzer? So useful. Oh my god. Oh my god, it shows everything. So useful. Thank you so much. Thank you so much. Thank you for hammer. Oh my god. Oh, nice. Okay, so this is how we call activate list. We start from crate and do boom 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 boom. Okay, and relative path. Is it how you do relative path? Front of house, like it doesn't feel like it's the right way. Posting at your whitelist. At your waitlist. Why does it not compile? You can imagine a file system with the same structure, and we specify paths to return the add to waitlist program. Okay? The path starts with the front of house, the name of the module defined at the same level as it has restaurant. So it's saying this and this are in the same level, so I can directly use it. Okay. Here the file system equivalent will be using the path. Oh, okay. So we do boom, boom, boom. The same. Oh, so if we move item definition codes separately from or together with the code that uses them. Oh, so if we move, the absolute parts might change. So sometimes it would be nicer to use relative paths, right? But also, if we move this function separately into another module, the absolute path will be the same, but relative path would need to be updated. So we need to think about both situations. When do we want to use absolute path and when do we want to use relative path? Our preference is to specify absolute path because it is likely we move code definitions and call items independently of each other. Okay, so preference is to use absolute path. Auto-completion syntax highlight. Ooh. You are already in front of house. Iteration is supposed to be at the root. Oh, I was so confused. So I'm not supposed to put it in here. I'm supposed to put it from here. Wait. Thank you for pointing it out. Oh. I can't press the right button. Good. So the public function is outside. It's outside. It's not inside the front of house. Ah, now it makes more sense. I was like, the restaurant is inside the front of the house. But it's actually on the same level. So we can directly use it. バカね、私。Yeah, it doesn't have any output for the code yet. So if we try to build it, it's gonna have an arrow. Let's try to build it. Cargo build. Huh? It doesn't have arrow? Why? Why is it okay? Nani? Oh, because I didn't save it. Tell me it's because I didn't save it. Oh, yes. So it's saying hosting. Oh, it even highlights. Hosting is a private module. Let's define it here. We have the correct path, but Rust won't allow us to use because we can't access private modules. So we need to respect the privacy boundary. The line that encapsulates the implementation details external code isn't allowed to know about, call, or rely on. So if you want to make an item-like function or struct private, you put it in a module. The way privacy works in Rust is that all items are private by default. Items in a parent module can't use the private items inside child modules, but items in child modules can use items in their ancestor module. This is neat. It's a very respectful parent that doesn't check a children's phone. Nice. The reason is that children modules wrap and hide their implementation details, but the children models can see the context in which they are defined. So the children can check parents' phone. Very nice. I can see what my parents are talking to. To continue with the restaurant metaphor, think of privacy rules as being like back office of a restaurant. What goes on there is private to restaurant customers, but office managers can see and do everything in restaurant in which they operate. Does this go with our example? I don't see which part. It's like hosting and serving. Rust chose to have module system function this way, so hiding inner implementation details is the default. That way, you know which parts of the inner code you can change without breaking outer code, but you can expose inner parts of child modules to outer ancestor module by using the pub keyword to make an item public. So if we add pub to hosting, we can use it. Oh, what? Rust Analyzer will run cargo check for you whenever you save and shows arrows inline. Oh, what? That is really neat. That is really neat. So that's why it's like showing an arrow. But arrows on the terminal are easier to understand. This is so cool. So cool. Exposing paths with the pub keyword. Let's return to the arrow that told us the hosting module is private. We want the Iterators function in the parent module to access the add to waitlist function in the child module. So we mark hosting module with the pub keyword. So we make it public, and it still has some problem because add to waitlist is private. So if we add a pub here, hosting still has error. I need to save. Oh, what does this say? Function is never used. That's a warning. I don't care about warning. So now it should be good. So if I run cargo build now, looks like it works. Just have some couple warnings. Just make sure the thing you're accessing are public and not supposed to be public. What? Among Us? Among Us is in Rust? No way. What language is Among Us? Returning. It's Unity and C#. I like how they deemed functions that are not being used. So after adding the pub in front of function, it works. Yay! Starting relative paths with super. What is super? We can also construct relative paths that begin with the parent module by using super at the start of the path. This is like starting a file system with the ... syntax. Why would we want to do this? Consider the code in here. So we have a function serve order, and in module back of house we have fix incorrect order and cook order. The function fix incorrect order calls the function serve order by specifying the path to serve order starting with super. So it goes back to the root and then can find serve order and access the serve order. The fix incorrect order function is in the back of house module, so we can use super to go to the parent module of back of house, which is in this case is crate. In the root. From there, so super goes to the parent module of back of house, which is the crate, the root. And from there we look for serve order and find it. So success. So we sync of back of house. We sync the back of house module and serve order function are likely to stay in the same relationship to each other and get moved together should we decide to reorganize Crate's module tree. So we think the back of house and serve order should be together. And the relationship stay the same. So we use super keyword. We don't need to update code if the code gets moved to different module. Ooh. Since it was server severe order previously, is super severe order now. Yeah, bet. Super severe order. This is super yabe. Okay, next making structs and enums public. We're serving breakfast. Oh yeah. We can also use past to designate struct and enums as public, but there are few extra details. Ooh, what details? If we use pub before a struct definition, we make the struct public, but the struct fields will still be private. We can make each field public or not in a case-by-case basis. So we are serving breakfast now. Where is the backup house? Wait, what? I didn't implement the backup house at all. So, okay, let's do it. We have module backup house. And it has a public struct. We're serving breakfast, big B, and we have a fill pub toast. It's a string. Toast is a string, and seasonal fruit. It's a string. But you won't allow us to access seasonal fruit. How cruel! And some method. This is an associated function. Not really method, but because it doesn't have a self. Public function summer toast a string slice, and then if you give it a toast and it returns a breakfast. So ignoring the return, it returns a breakfast. Ooh, did it for me? Toast, seasonal fruit. Toast is a string from toast. Oh. So you pass in the name of the toast, and seasonal fruit will always be peaches. I like peaches. Nice choice. So you pass a string literal of a toast, and breakfast will have the toast and peaches. Cyan sensei, do you know JavaScript? I know a little bit. Good enough to Stack Overflow it. By the way, you can mark things as pub crate, which limits them to only ever being visible inside the current crate. Oh, so I can do like pub crate. Ooh, fancy! No, welcome, hello! How are you doing? So we have our breakfast and the function eat at a restaurant. Oh, so what is a rye toast? Rye toast. So hungry. I'm so hungry. Huh? It's kind of bread made with various proportions of flour from rye grain. It's dark in color. Ew. Do people like to eat this? With Rust Analyzer, there is also a shortcut for auto-formatting while Rust Format. I don't know the details of keyboard combination, but the command is called Format Document in Command Palette. Can I just do Rust Format? Oh, what happened? Is it asking for an argument? I'm relearning frontend now. 2 years didn't touch any coding scene. Ganbatte! I want to learn frontend recently too. Ganbatte! They're just... the frontend things just change so quickly. So many changes. At the very beginning it was just HTML and CSS, but now we got so many things to learn. So many libraries. What ID is this? Is this video? This is Visual Studio Code. Rye bread is very popular in Russia, and I heard it's a little bit healthier than regular bread. Really? Really? I might try it. I can do cargo format. I like cargo. Cargo is so cool. Huh? Huh? Oh. What? Okay, I think you formatted it. Rust format will wait for input from stdin. Oh, it is from the terminal. I see. Thank you. Command Shift P. Oh. Command Shift I. Oh. Format. Oh, Command Shift Alt F. Ooh, okay. So many shortcuts. Thank you. Okay, define eat at a restaurant. Order a breakfast in the summer with rye toast. Let mute meal equals to back of house breakfast summer rye. Print line. I'd like toast, please. How much time did it take you to learn enough code to apply for a company? It really depends on the person and what type of job. I heard people like shortest they can do it in months or years. At least 6 months to say be entry level for front end. but like for full stack, it's probably gonna take years, at least 2 years of learning, of like very concentrated learning, I think. Some companies are willing to teach you themselves, while others just want only experienced programmers. Yes. Tom Mickey, thank you for subscribing. Welcome to Neostar. The job title matters too. But normally, like if you get a computer science degree, that's gonna be 4 years. And some people go ahead and get a master, that's gonna be like 1 to 2 years. So it's a lot of time. Okay, what did I do? What happened to the mail? Will this work? So from the back of the house, we get a breakfast. And we use our summer function to get a rye toast. And then you turn up breakfast. So if I do kako build, kako run. Oh, I can't run. I can only build. Oh, I need to call this function. Oh. Because the toast failed, in the struct is public, Iterators, we can write and read into the field using the this dot notation. Because it's public, the fields are public. If you look like this, the function is public, and the field in breakfast, the toast, is public, so we can read it. Otherwise we won't be able to. And we can't use dots to do seasonal fruit because seasonal fruit is private. So if we change this to seasonal fruit, the Rust analyzer says this is private, so we can't access it. Oh! In contrast, if we make an enum public, all of its variants are then public. We only need the pub before the enum keyword as shown here. Okay. So in the back of the house, we have a public enum, a big A, appetizer, and then we have salado, soup, and salad. And then since it's public, all the structs are public. And here in the Eat at Restaurant, let order 1 equals to back of house appetizer soup. Order 2 equals to salad, both of them will work because the enum appetizer is public. All the variants become public. Hum. I don't know if my basic knowledge about HTML, CSS, and JavaScript are enough for startup prompting or not. Look at their job description. They usually use specific tools and libraries. I think React is like the most popular ones recently. And front end. Do you need a portfolio? Because you need stuff to put on your resume. So build some project yourself. Build your personal website. You should Google how to be a front-end engineer. Cyan in a job interview be like, I can do front-end and back-end. Interviewer, doesn't matter, you're cute, that's enough. It doesn't happen. I was once in an interview and the interviewer was like, hey, we hire people who can code. We don't hire cute people. I was pretty sad. that was pretty sharp. No, they don't hire you because you're cute. They hire you for the money. Yeah, like bigger companies is more relaxed and you have more time to learn. They have a system, mentor system for you to grow and accessible courses for you to take. But startup is a lot of competition and work. 超级性感，波光粼粼，大包猫，耳朵大姐姐，超牛的名字。是很早以前就来看直播的一位伙伴。And overall, I'm more willing to hire novices because they don't need to worry about investors as much and have funds to spare. Yes. I'm on a hiring committee and I did hire Italy girls like go to a Zoom meeting. What's my cat years? Is it like some people hire a farm animal to go to the Zoom meeting to make people stay focused? If it gives me like 130k a year, I will be gladly to do it as a cheerleader for the team. Hello underscore, welcome. Good morning. Okay, where are we now? We're saying though everything in enum. If enum is public, then everything in enum is public. Enums aren't very useful unless their variants are public. It will be annoying to have to annotate all enum variants with pub in every case, so the default for enum variants is to be public. Structs are often useful without their fields being public, so struct fields follow the general rule of everything being private by default unless annotated with pub. There is one more situation involving pub that we haven't covered, and that's our last module system feature, the use keyword. We're going to learn the use keyword. We will cover use by itself first, and then we will show how to combine pub and use. Bringing paths into scope with the use keyword. It seems like paths we have written to call functions so far are inconveniently long and repetitive. Yeah, use is very long. Fortunately, there is a way to simplify it, we can bring a path into a scope once they call the items in that path as if they are local items with the use keyword. What? So let's bring the create front of house hosting module into the scope of Iterators restaurant. So to do that, we have a Iterators restaurant, and we use keyword. Use create front of the house hosting. And in the hosting, we can access the hosting. This is nice. What is this? Doesn't matter. Oh, works. Adding use and path in scope is similar to create a symbolic link in the file system. By adding use create front of house hosting in the create root, hosting is now a valid name in the scope. Just as though the hosting module has been defined in create root. Oh, so we put use in the create root. We put hosting in the create root, so we can access it as if it has been defined in the root. Paths brought into scope with use also check piracy like in other parts. So we need to be mindful to use public or not. We can also bring an item into scope with the use and relative paths. Like this. Oh, we need to use self. If I don't use self, what's the arrow? The pop crate syntax is meaning it's only public in this crate. I was just using it for fun. Chat told me, if I do cargo build, will this build? Looks like it's okay. No arrow. But I'll just put a self there. Wait, what? It doesn't want me to put self. Why? Now it's all of a sudden it's okay. Creating idiomatic use path. So why did we put this entire thing rather than the use path? What is idiomatic? Idiomatic. Rust Analyzer can automatically add use for you. If you without having what? So if I don't have this, and use this. Will they add it for me? Quick fix. Import? Oh! What just happened? What does it do? It add the use for me. At the very top. But you forgot to add the... Now it's good. If I save, the error goes away? I mean, yeah. It worked. Okay. Okay? Okay, it worked. Okay. Nice. So you guys do all this magic to let it code for you? So amazing. So amazing. Although both of them accomplish the same task, listing is the idiomatic way to bring a function into scope with the use. So this is the idiomatic way to bring it into scope. Bringing functions parent module into scope with use means we have to specify the parent module when calling the function. Specifying the parent module when calling the function makes it clear that the function isn't locally defined while minimizing repetition of the full path. Specifying the parent module when calling the function makes it clear that the function isn't locally defined. So confused. Let me read it again. So it's saying this and that has the same task. Oh, this one has the hosting, but this one doesn't. We usually do this. Because and we need to specify the parent module, and it makes it clear it is not locally defined. Okay, but this one you have no idea if it's locally defined or not, so we usually do this. Okay. If you are using IntelliJ, they have a hotkey that write code for you. Really? Had a few people use Python for machine learning at my first job, but the project was written in Swift and Kotlin. Oh, it's mobile. Machine learning or data science people, right? Machine learning engineer. Like you can have it auto write trait stubs. Ooh. I used IntelliJ for Java, and it was Java isn't that pleasant, but IntelliJ made it pretty much pleasant. On the other hand, when bringing structs, enums, and other items with use, it's idiomatic to specify the full path. So when we bring struct, enum, and other item with use, like this Hashmap, we should specify the full path. And the exception is if we are bringing two items with the same name into the scope with the use statement, because Rust doesn't allow that, so we can't bring two items with the same name into the scope with the use. We need to do something else. We need to the two result, and you need to use the namespace to show there are different ones. Okay. Oh, Control Plus can do that too? Nice. Using the parent module distinguish the two result types. Oh, so we use the parent module to differentiate those two. If instead we specify the use std format result and use std IO result, then we have two results and Rust will like it. Oh, you can do it as? That's neat. Renaming is neat. Oh, there's... What? It's Control plus dot. Okay. It's a period key. Wait, what? It's so hard to tell if it's a period or a dot. But I know what you mean. It's a dot. Control plus dot. Providing new names with the as keyword. Oh, nice. As flashes, you get it right. New name can be renamed using as. Re-exporting games with pub use. Pub use. Why do we need pub use? Well, when we bring a name into scope with the use keyword, the name available in the new scope is private. To enable code that calls our code to refer to the name as if it had been defined in that code scope, we can combine pub and use. So we use keyword to bring hosting to scope. Hosting our scope, the name available in the new scope is private. To enable code that calls our code to refer to that name as it has been defined in code scope, we can combine pub and use. This technique is called re-exporting because we are bringing an item into scope, but also making that item available for others to bring into their scope. So we use pub/use for hosting. External code can call add to waitlist using host add to waitlist. If we didn't specify pub/use, then the eat restaurant function could call hosting add to waitlist in its scope, but external code couldn't take advantage of this new path. Oh, so eat at the restaurant doesn't care about this, but external code can use this scope. Does it show any external code? It doesn't. Ho. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code will think about the domain. For example, in this restaurant metaphor, the people running the restaurant think about the front of house and back of house, but customer visiting a restaurant probably won't think about the parts of the restaurant in those terms. With pub/use, we can write out code with one structure, but expose a different structure. Doing so makes our library well organized for programmers working on the library and programmers calling the library. Okay. So when people want to use something, we give it a pub, so everybody can drink the way they want to. Hello, Waya-san. Good morning. Using external packages. In Chapter 2, we programmed a guessing game project that used an external package called ren to get random numbers. To use ren in our project, we add this line to cargo tomo. Okay? Cargo tomo. Dependency. Ren equals to 0.8.3. If you put pub/use hosting at the waitlist into the front of house modules, then the external code, that is the code on top level, could use front of code at the waitlist. So if I put you mean I put it in here? So I can use front of house. I'm confused. I'm confused. I think I'm doing it wrong. Okay, let's look at the external packages. Oh, this is a long example. Let me copy the wording. I did it right? Self-doubt. Okay, this is the number guessing game we had. And we'll use the external crate rent. Members of the Rust community had made many packages available at crates.io. Oh, what is green? Ah, everybody download Ren. Live C. Cool. Nice. And pulling any of them into your package involves the same step. Listing them in your package cargo tomo file and using use to bring items from the crates into scope. Note that the standard library is also a crate that's external to our package. Because the standard library is shipped with the Rust language, we don't need to change cargo.tomo to include std, but we do need to refer to it with use to bring items from there to our package scope. So if we want to use something in the standard library, we don't need to put it in the tomo, but we can. But we have to do use like this. Oh no, Russ, welcome Donald, how are you? And your cat? Using nested pods to clean up large use lists. What is large use lists? Oh, we can use nested pods to make the use statement shorter. If we are using multiple items defining the same crate or same module, listing each item on its own line can take up a lot of vertical space in our files. Okay? Oh, we can nest them to bring the same item into scope in one line. Oh, so simple. I like it. So basically, we can do this. Just combine the lines together with the curly braces. Oh, nice and simple. Hello, Jesus. Welcome. In bigger programs, bringing many items into scope from the same crate or module using the nested pods can reduce the number of separate use statements needed by a lot. Yes, this looks right. So clean. We can use nested pods at any level in a path, which is useful when combining two use statements that share a subpath. For example, we can combine this together in the globe operator. If we want to bring all the public items defined in a path into a scope, we can specify a path followed by a star. The globe operator. What? You're called globe? I thought you were a star. Use the std collections globe. So all the public items in the collections will be bring to the scope. But it will take a lot of space, right? If we take everything. Globe can make it harder to tell what names are in scope. Oh, but we have std. Okay. Globe can make it harder to tell what names are in scope and where a name used in a program was defined. Oh. Okay. I had a brain freeze. The globe operator is often used when testing to bring everything under test into the test module. Okay. The globe operator is sometimes used as a part of a prelude pattern. Okay. Okay, last one. Separating modules into different files. So far, all examples in this chapter define multiple modules in one file. When modules get large, you might want to move their definition into separate files to make the code easier to navigate. Okay, finally we are making more files. Not just one big file. For example, let's start from the code and move the front of the house to its own source front of the house by changing the create root file so it contains the code shown in there. So here, this is the library. This is the restaurant. This is the front of the house. Is this the front of the house? What is this? No way. This is the main function. And then we want to create a new file called front of house.rs. And then we put the mode in there. So the library imports front of house and do that. Use a semicolon after front of house. Use a semicolon after this rather than using a block to tell Rust to load the contents of the module from another file with the same name as module. So you use mode plus the file name to import the other file as a module. We change, so we're further separating it to only have part mode hosting and have a file, new file, hosting.rs to have the contents of a hosting. But more hosting. The module tree remains the same, and the function calls in it and restaurant will work without any modification. Really? What? The main function is in the hosting? So we define a function here. We need to have another directory. Why do we need another directory? Front of house. So we put posting in. And hosting is a main function, and now we can import this. Can I go into it? It does have a active waitlist. That seemed like there was a lot to learn last time I looked at it. Yes, it's a lot. It's a very long book. Not very long, but a bit longer than I thought. Add to waitlist. But hosting does have an add to waitlist. Okay, fixed. I was like, there shouldn't be a main function. So hosting has this add to waitlist. Front of house gets the module of hosting, and here we use hosting from the front of house, and here we still refer to the parent. Oh, okay, got it working. Summary: Rust lets you split package into multiple crates and a crate into modules, so you can refer to items defining one module from another module. You can do this by specifying absolute or relative paths. This path can be brought into scope with a use statement, so you can use shorter paths for multiple uses of item in that scope. Module code is private by default, but you can make definition public by adding the pub keyword. In next chapter, we are going to look at some collection data structure in the standard library that you can use in your neatly organized code. Okay, let's go! Let's hit the next chapter. Common collections. Oh, vector, string, and hash. Let's go! Rust standard library includes a number of very useful data structures called collection. Most other data types represent one specific value, but collection can contain multiple values. Unlike the built-in array and tuple types, the data this collection points to is stored in heap, which means the amount of data does not need to be known at the compile time and can grow or shrink as the program runs. Each kind of collection has a different capabilities and costs, and choosing an appropriate one for your current situation is a skill you'll develop over time. In this chapter, we'll discuss 3 collections that are very often used in Rust. A vector allows you to store variable a number of values next to each other. A string is a collection of characters. We mentioned in the big stream type previously, but this chapter we'll talk about it in depth. A hash map allows you to associate a value with a particular key. It's a particular implementation of the more general data structure called map. To learn about other kinds of collection provided by standard libraries with documentation, we'll discuss how to create and update vectors, strings, and hash map, as well as what makes each one special. Okay! Common libraries, let's go. I like vector a lot in C++. You've coded, hello. Do you guys know each other? Our chat is like a big family. Are you guys from the FANG companies? Send me a recommendation. What was it? Recommendation? Reference? Referral. Welcome, Angelo. This is coding. We're learning the collections in Rust. I came with you. What made you want to learn Rust? People say it's cool, so I wanna learn it. Chat is a union. We worked together on some Minecraft command block stuff like 8 years ago. Ooh! You guys play Minecraft? I have a Minecraft server. Runs 24/7. I sometimes play stuff with viewers on it. Probably gonna do it next week. I do have a Minecraft server. I want to bring more people in to do like fun stuff and build buildings. You already know Go well? I want to be good at Go. Storing lists of values with vectors. The first collection type we'll look at is vector T, also known as vector. Vector allows you to store more than one value in single data structure that puts all the values next to each other in memory. Vector can only store values of the same type. They are useful when you have a list of items, such as lines of text in a file or the prices of items in a shopping cart. Okay, I just remember using it for everything. When I first started C++, creating a new vector. To create a new empty vector, we can call the new function. Okay, I think I should create a new project. The restaurant one is very messy. Cargo new budget. Where is my budget? I have so many. Source main. Okay, let me close those up. Don't save. Huh. Okay. Okay. Where's okay, it's here. Hello world. So if I want to declare a vector, I32 equals to vec new. Note that I added a tab annotation here. Because we aren't inserting any values into this vector, Rust doesn't know what kind of elements we want to store, so we're telling them we want to store a 32-bit integer. Vectors are implemented use generics. We'll cover how to use generics with your own types in Chapter 10. For now, know that the vec_t type provided by standard library can hold any type, and when a specific vector holds a specific type, the type is specified with an angle brackets. Okay. In more realistic code, Rust can over-infer the type of value you want to store once you insert value. So really you need to do this tab annotation. It's more common to create a vec_t that has initial values. I like it. And Rust provides the vec macro for convenience. The macro the macro will create a new vector that calls the value you give it. Okay, so I can, instead of creating a new vector like that, I can do v equals to vec 1, 2, 3. Nice and easy. Nice and easy. Updating a vector. So we need to declare it as mutable. And then we can push stuff into the vector. 5, 6, 7, 8. And I can pre-print this. Cockle run. Okay, we got a vector with 5, 6, and 7, 8. As with any variable, if we want to be able to change its value, we need to make it mutable. Hey, easy peasy. Dropping a vector, drop its element. Oh, so if it goes out of scope, the elements will be gone too. So it's gonna be complicated if we have reference in the elements of the vector. Reading elements of vectors. Now that you know how to create, update, and destroy vectors, knowing how to read their content is a next good step. Okay, there are 2 ways to reference a value stored in vector. What are the 2 ways? The first way is so we have a vector v equals to vect 1, 2, 3, 4, 5. Pitasho, welcome. And we'll let third equals to 4. No. Third. A reference. This is how we take the third one. Debug third. And match, we don't get to. This we're doing matching. Why? Some third. Why is it optional? Print line. Third. No. Nothing. Okay, so we use the index value of 2 to get a third element. Vectors are indexed by number, starting at 0. Second, the 2 ways to get the third element are using a reference and square brackets. Or we can use the get method. Oh, does the get method return a optional? Where did my Rust analyzer go? It disappeared. So if I do code go wrong... Ah, what's up BTG? Debug. Okay. The third element is 3. 3 equals to 3. So it does have something. The vanishing Rust analyzer. Sometimes you do Marco Harris or just stop working. Oh no. Come back, analyzer. Oh, I need to open the project directory? How do I... open the project directory? File, open folder, documents. Okay. Oh, okay. Rust analyzer is back. Okay, cool. It's back. So get does return an option. That's why we need to handle some or none. Soka. It worked. Thank you. We use index value of 2 to get the third element here. And vectors are indexes with numbers starting at 0. Second, 2 ways to get the third element are using... Oh wait. Oh, this is the first. This is the second. Reference and bracket. And get method gives us a option. Rust has 2 ways to reference an element, so you can choose how the program behaves. So here... Oh. So if we reference something that doesn't exist, what's gonna happen? Oh. It wouldn't even let it compile, right? Yeah, pretty simple stuff. Pretty simple stuff. Where did my terminal go? Oh, okay, it's back. Nice. Kako. Really? They only have warning. It doesn't complain. So if I do Kako wrong, what's gonna happen? It's not used, so it doesn't care. What? I didn't know. Oh wait, hold on. It panicked. Yes, it panicked. It panicked. It doesn't like it. Good. Good. Oh, what? It was hiding in a bar? I didn't know that. Oh, okay. Cool. Control plus dot. Oh. I think it doesn't work because my keyboard is very short. Like my keyboard is tiny and it doesn't have the, like, I need to have a special key combination to bring up arrow, left arrow, and the dot. So it's so hard. I can't use that extra hand. Allow that code. What? So. Can I roll it? Ooh. Nasty. Nasty? Nasty. What percent keyboard do I have? I don't know. It's like the smallest keyboard I can find. It doesn't even have arrow key. I have to press a function key to get the arrow key. It's not ideal for coding, I feel. Okay. So the first thing will cause the program to panic, just as we saw. It panicked. This method is best used when you want your program to crash, if there's an attempt to access an element past the end of a vector. What? You want your program to crash? Okay. When a get method is passed, an index that's outside the vector, it returns none without panicking. Oh, what? So if I use a get method, it doesn't panic. Don't give me super chat, stop. I have better keyboard. I just want to use a small keyboard because my table is not that big. But thank you for a super chat, Petomi. I won't buy a new one. Limb control will probably still work without arrow keys. Oh yeah, I use J and K. I don't know, I might really buy a new keyboard. If you use get, it becomes an optional and you can match that option. Oh, so get won't crash a program. It returns none without panicking. You will use this method if accessing an element beyond the range of vector happens occasionally under normal circumstances. Your code will have a logic to handle either some or none, as discussed in Chapter 6. For example, the index could be coming from a person entering a number. If they accidentally enter a number that's too large and program gets a null value, you can tell the user how many items are in current vector and give them another chance to enter a valid value. This would be more user-friendly than crashing the program due to a typo. Yes, yes. When the program has a valid reference, the borrow checker enforces the ownership and borrowing rules to ensure this reference and any other reference to the contents of the vector remain valid. Recall the rule that states you can't have mutable and immutable reference in the same scope. That rule applies in here, where we hold an immutable reference to the first element in a vector and try to add an element to the end, which won't work if we also try to refer that element later in the function. So what's going on here? What's going on here? We have a vector and we have a immutable reference to the first element. And then if we try to edit the vector, we are borrowing a mutable reference here, and it wouldn't let us do it. So let's see what's the arrow. So there is a mutable arrow in the push, and there's an immutable borrow later being used, so this cannot happen. Adding an element onto the end of a vector might require allocating new memory and copying the old elements into new space. If there isn't enough room to put all the elements next to each other where the vector currently is, if there isn't enough room to put all the elements next to each other where the vector currently is, adding a new element might require allocating new memory. And in that case, the reference to the first element would be pointing to deallocated memory. The borrowing rules prevent programs from ending up in that situation. So why does it not work? It's because adding an element to the end of the vector needs new memory, might need new memory, and we need to copy the old elements into new space. If there isn't enough room to put all the elements next to each other, then we need to find a new space, and reference to the first element will be pointing to a deallocated memory, so this reference will not be pointing to our read. So Rust doesn't like that, so it won't happen. Time to go back to fundamental concept. Yes, foundational concept. Iterating. Oh, I like this. For I in this print line, macro. So this prints everything. Bang. We can also make it mutable and do a mutable borrow. And with the reference, we get the value of I and we add 50 to it. And if we print line, the I, it's gonna be 51, 52, 53, hopefully. Yeah. They're referencing so much. What was that voice? I'm good. What? What happened? Thank you for coming, Tita. Have a good night. I'm good. What? What did I do? I was just stretching. Cool. 我做了什么？我做了什么？我刚刚发出了什么声音，把大家都吓到了 ？What? What did I do? I'm so confused. I was just scratching. Did my nose hit the camera? No, my nose hit the microphone. What? You guys are weird. Okay. Keep going. Keep going. Use enum to store multiple types. At the beginning of the chapter, we said vectors can only store values that are the same type. This can be inconvenient. There are definitely use cases for needing to store a list of items of different types. Fortunately, we can use the variants of enum because they are defined under the same enum type. Cool! We want to get values from a row in a spreadsheet in which some of the columns in a row contain integers, some floating point numbers, and strings. Okay, we can define an enum whose variance holds different value types, and then all the enum variants will be considered the same type, that of enum. Then we can create a vector that holds that enum and so ultimately holds different types. Okay. Let's read this. So we have an enum of spreadsheet cell. Integer I32, that's the first tuple variant, tuple struct, and float f64. Wait, what? There's an easier way to write the photo. I'll be so sad. I spent so much time learning the harder way. And we have defined our enum let row equals to vec. Oh, come on. Okay, come on. Spreadsheet cell integer 3. Spreadsheet cell float 3.5. Spreadsheet cell text string from Nya. Okay, what are you complaining about? You douchebag. Oh, no semicolon. That's still a lot of complaint. What do you not like? I need a main function. Ah. Hold on. How do I do a main function? Like this? Like this? No. I forgot how to write a main function. It's like this. I define enum inside 的没方看。Font keyword let. Oh, save the file. Okay. Location of enum doesn't matter. Okay. So I can just I want to put it outside. Oh. Nice. Okay, we have our row. Can we like print DPG row? What's gonna happen? Oh, it cannot be formatted because it's very special. Doesn't like getting print, huh? Because I didn't put derive. Wait, what? But I thought I only need derive if I use print line. Well, maybe I was wrong. Let me try again. Did I really learn Rust? I guess it takes practice. Okay, worked, thank you. I'll remember to use derive. Because this way... it takes the display in the debug, so you can show. Okay, lesson learned. For DPG, printing debug is necessary too. Okay. So people usually debug with the print line. Soka. Okay, moving on. Rust needs to know what types will be in vector at compile time, so it knows exactly how much memory on a heap will be needed to store each element. A secondary advantage is that we can be explicit about what types are allowed in this vector. If Rust allowed a vector to hold any type, there would be a chance that one or more types would cause errors with the operations performed on the elements of the vector. Using an enum plus a match expression means that the Rust will ensure at the compile time every possible case is handled. When you are writing a program, if you don't know the exhaustive set of types the program will get at runtime to store a vector, the enum technique won't work. Instead, you can use a trait object, which we will cover in chapter 17. Now we discuss some of the most common ways to use vectors. Be sure to review the API documentation for all the many useful methods defined on vect by the standard library. For example, in addition to push, there's a pop that removes the last element. Okay, let's take a look. So you have a push, you have a length, you can access the index, you have pop, will pop the last element, and there's a iter copied. Wait, what? Is that a shorthand for loop using the iterator? People don't usually do it. Oh, using this consume the vector, I should use the reference. Rastos has a dark theme. Dark, where are you? Dark theme! Are you? Do you like dark or are you? I like are you. Should my stream background also be like the layout? Should it also be dark theme to match to make everybody comfortable? Ayu looks good. I like Ayu. Print line always work. Print line. Roll. Okay. Show me your power. No. No. Looks like print line also need this thing. If you wanna use it, you need to have this derival. Yes? Yes? Yes. Cuckoo. Moving on. Let's look at string. UTF-8. What the heck is that? We talk about strings in chapter 4, but we'll look at them in more depth now. New Rustaceans commonly get stuck on strings for a combination of 3 reasons. Rust propensity. Propensity? What's a propensity? An inclination or natural tendency to behaving particularly. Then just use tendency. Rust propensity for exposing possible errors. Strings being more complicated data structure than many programmers give them credit for, and UTF-8. Propensity, okay. These factors combine in a way that can seem difficult when you are coming from another programming language. It's useful to discuss strings in the context of collections because strings are implemented as collection of bytes, plus some method to provide useful functionality when those bytes are interpreted as text. In this section, we'll talk about operation on string that every collection type has, such as creating, updating, and reading. Okay? We'll also discuss the ways which string is different from other collection, namely how indexing into a string is complicated by the differences between how people and the computer interpret string data. What is a string? What is a string? I always confuse why it's called string. String is a literal is an object. Why is string called a string? They're just text. They're not string. But anyways, we'll first define what we mean by the term string. Rust has only one string type in the core language, which is the string slice, the small string that's usually seen in its borrowed form reference to the small string. In chapter 4, we talk about string slices, which are reference to some UTF-8 encoded string data stored elsewhere. Okay? String literals, for example, are stored in programs binary and are therefore string slices. String literals are binary. The big string type, which is provided by a Rust standard library rather than coded into core language, is a growable, mutable, owned UTF-8 encoded string type. I see people mention this UFO stuff so many times. What is UTF-8? It's a variable with character encoding used for electronic communication. It's an encoding. A guide for non-programmers. Teach me, enlighten me. Okay, so I start from binary and then Ascii converting numbers to binary. A way to store every symbol. It assigns a unique code called code point to each character. Code point. Huh. What is this? It's a UTF-8 is a encoding system for Unicode. It can translate any Unicode character to a matching unique binary string, and can also translate the binary string back to the Unicode character. Oh, that's why strings are binary? UFO stuff. It looks like UFO. It's encoding for Unicode that's backwards compatible with Ascii too. Ascii too. Cyan has a dead brain today. It's an encoding for Unicode that's backwards compatible with Ascii. UTF-8 essentially is the text and emoji you see every day. UTF-8 is Ascii but with Unicode, so you get emoji. Unicode lets you use multiple bytes to represent characters. Apple is nauseous for getting the parsing wrong. You are entering a rabbit hole. Okay. Unicode is why you can write Latin, Greek, Chinese, and Arabic text in the same file with no problem. Oh. Oh, sorry, no doxing, okay? Okay, we're back to the doxing. Thank you for the explanation to this UFO-8. Okay, let me read this again. So, string slices are references to some UTF-8 encoded string data stored elsewhere. String literals, for example, are stored in the program's binary, and are therefore string slices. Okay. To represent a string, each character needs to be encoded as a number. There are multiple ways to do that, and UTF-8 is a very common one. The important part is that it uses number from 1 to 4 bytes as a representation. As a result, if you want to know where the 10th character is, for example, you need to iterate over it since you don't know how large the first characters are. Oh. I'm calling UTF-8 UFO from now. Okay. UFO-8, let's go. There used to be an iPhone bug where someone sent a specific Unicode character, your phone crashes and shut up. Yeah, I remember it. It was on TikTok and everybody can't wait to get their phone shut up. Rust characters are 4 bytes in contrast to C 1 byte, so a single character can store a large UTF-8 symbol. Ooh, すごい. Rust characters are 4 bytes. That would take a lot more space. But is it because like space is cheaper now? This what the fuck? 8? Oh, did I just say it? What is that? Is that an encoding? I can't control myself. Oh, it's not that word. It is wobbly transformation format. Uh-oh. The encoding rabbit hole. Yep. Stop. I don't wanna go. Everybody's so happy about encoding. Why? A string is not an array of charts, so no space is lost. Oh. So using UTF-8 by default is very convenient. You can still convert your string to a byte slice and index into it however you like. Everybody is using UTF-8. Yes? Get out of the rabbit hole and start making some strings. Okay. Okay, I'm out of the rabbit hole. What is a string? The big string is scrollable, mutable, owned, UTF-8 encoded. Cool. Our standard library also encodes a number of other string types, such as zero string, C string. What the heck? Library create can provide even more options for storing string data. See how those names all end with big string or small string? They refer to owned and borrowed variants, just like string and string types. Why? Are there so many strings? These string types can store text in different encoding or be represented in memory in different way. For example, okay, we won't discuss these other string types. See their API. Okay. It's OS of operating system. Okay. That's not a zero, that's an O. Okay. Creating a new string. Copy. This line creates a new empty string called S, which we can load the data to. Often we'll have some initial data that we want to start the string with. For that, we use the toString method. So don't we usually use like from, string from? Let data equals to init content. Let s string equals to data dot to string. To string. Let string equals to. Okay, it is stuff. Should just magically work. Type up. Rust code supports Unicode. I can do that. Let mail goes to Cyan. Print line. I personally wouldn't like the idea of putting Unicode characters into code. It just feels so foreign if it's not completely English. It's weird. You can write other languages in Rust. It works. You've seen a lot of Chinese code on Project Rust, really? This is so weird. I turn off noise cancelling today, so you guys can hear like my earphone sound and keyboard sound and cat sound. So many sounds. I need to give it a listen after this. Anyways, that's how you initialize strings. Oh, what? 안녕하세요. konnichiwa. Hello. Glory Dan. Hola. Hola. So many. We can include any properly encoded data in them. You know. There's a lot of strings. There's a lot of strings. Updating a string. Push string. You use push string. String from foo. What does foo mean? Why does everybody use foo? S.push string bar. Yeah, what does a full bar mean? Is it a bar? Print line. S. Hello Emerson, welcome. Full bar is stolen from military people? What is that? What is a full? What is a bar? Is it like iron bar? Full bar. Full bar is just an example. Then people use, but there must be a reason. Wikipedia. After these two lines, S will contain full bar. Yeah. The push string method takes a string slice because we don't necessarily want to take the ownership of the parameter. For example, the code here show you'll be unfortunate if we won't be able to use S2 after appending its content to S1. So we use a string literal. If we move this into S1, we won't be able to use S2, right? Who was a comic in the 1930s? What? Bye Emerson, have a good day. No? Esther's still here. What? Wait, what? Oh. It doesn't take ownership. Wait, what? My brain. So the push string takes a string slice. S2 is a string slice. So it works. But what if S2 is a big string? This way S2 won't work. Oh, actually it doesn't even take big string. It only takes string slice. So it works. Cool. If pushString method takes ownership of S2, we wouldn't be able to print this value. Okay, the push method takes a single character as parameter and adds it to the string. So we can add a single character as well. Yeah. Oh, I can reference it. What? It doesn't like the single character. Oh, what? Push take a single character. What? Why make it so special? Fua. Why do we make it special? Why do we have a push character? Because it's different type. It's a character. It's not a string slice, so it doesn't want like to. So it's a separate function. Okay, string from and I borrow it. This should work, guys. We have a S2 is here. I want to know what S1 is. S1 should be funya. Yeah, S1 is funya. Because there's no overloading Rust. Oh. So I got to remember more methods. Cool. No. Concatenation with the plus operator. Plus operator, like this. S1 has been moved here and can no longer be used. Oh, so if we concatenate, S1 cannot be used. But S2 can be used. So if we do print line, S1 is gonna say S1 is gone. But if we do print one S2, because we only borrow it for concatenation, it says world. Yay! Reference of big string can be automatically converted into small string. Woo! What? There's a concat shorthand macro. So if I do hello Sanitas, welcome back. So if I do concat S1, S2, S3, do I need to put the references in? Oh. So we put them into, is this an array and concat? Oh, looks like it's sort of working. No? Flattens a slice of t into a single value. Does it talk about concat? Ah, it does. Okay. Format. Format S1, S2. If I do this, oh, where did Hello World go? The format doesn't print. Do we want to do this? Format returns a string. Oh, nice. Nice. Yes, this is the last. Thank you for the super chat, Warrior-san. Arigato. Arigato. Thank you. S1 is no longer valid about adding and the addition, and the reason we used a reference to S2 has to do with the signature of the method that gets called when you use the plus operator. Okay. Add method looks like this. Looks something like this. That is defined using generics. We can only add a string slice to a big string. We can't add two string values together. compile. This compiles because this one is reference. The compiler coerce the big string argument into a small string. When we call the add method, let's use the deref coercion. What are you? Coercion. Deref coercion, which returns S2 into that, which is a string slice. We'll discuss deref coercion in more depth in chapter 15. Because add does not take ownership of the s parameter, S2 will still be valid after string. Well, S2 will still be a valid string after this operation. Ooh. Second, we can see that in the signature that add takes ownership of self because self does not have an reference. This means S1 will be moved into add call and will no longer be valid after that. So after this, it will take the ownership of S1, appends a copy of contents of S2, and then returns the ownership of the result. In other words, it looks like making a lot of copies, but isn't. The implementation is more efficient than copying. If we need to concentrate multiple strings, if we need to concatenate multiple strings, the behavior of the plus operator gets unwieldy. Unwieldy? Difficult to carry. Unwieldy. Oh, so if we do this, S will be tic-tac-toe, but looks like S1 will be gone. For more complicated string combining, we can use format. Boom, 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 boom. It doesn't print. It returns the big string. So we should use format to concatenate in Rust. Why do the docs use English words that almost nobody uses? I'm confused. Why? Welcome, free cat. Indexing into strings. In many other programming languages, accessing individual characters in a string by referencing them by index is a valid and common operation. However, if you try to access parts of a string using indexing syntax in Rust, you'll get an error. So this will get me an error. This looks really common in other languages, but Rust just doesn't like it because string cannot be indexed by integer. Rust strings don't support indexing, but why not? To answer the question, we need to look at the memory. They want to teach us two languages at once. One bird, two stones. I haven't seen those words in SAT. I think even GRE doesn't have those words. You can make PR to make docs use normal English words. I think my biggest struggle is cannot understand English. Okay, those are just jokes. Don't take it seriously. Internal representation. A string is a wrapper over vector. Let's look at some of properly encoded UTF-8 example strings. Okay, so we have a hola. In this case, length will be 4, which means the vector storing the string hola is 4 bytes long. Each of these letters takes 1 byte when encoded in UTF-8. But what about the following line? This is not 3, this is Z? Oh my god. Ask how long this string is, you may say 12, but however, Rust's answer is 24. That's the number of bytes it takes to encode this in UTF-8, because each Unicode scalar value in that string takes 2 bytes of storage. Therefore, an index into the string's bytes will not always correlate to a valid Unicode scalar value. To demonstrate, consider this valid Rust code. This. The answer should be the first letter, right? Wait, no! This will be the half of the first letter because it takes 2 bytes. What should the value of answer be? Okay, so what should the value of answer be? The first byte of this fancy Z is 208, and the second is 151. So the answer would be 208, but 208 is not a valid character on its own. Returning 208 is likely not what user will want if they ask for the first letter of this string. However, that's the only data that Rust has at byte index 0. Users generally don't want the byte value return, even if the string contains only Latin letters. this will valid code that return the byte value, it will return 104, not H. Ooh. To avoid returning an unexpected value and causing bugs that might not be discovered immediately, Rust doesn't compile this code at all and prevents misunderstanding early in the development process. Oh. So if we wanna do it, it's gonna say so we can't. We just can't. Even with the reference, still can't. Because we don't want to return half of a byte or not the character we want. Bytes gather values and the graph meme bar hear me? What is a graph meme? What is that? Another point about UTF-8 is that there are actually 3 relevant ways to look at strings from Rust's perspective: bytes, scalar values, and graph me. Graph me is a symbol? What the heck? I never heard of this in my entire life. Graph me? In the smallest meaningful contrastive unit in writing system? Graph me is the smallest functional unit of a writing system. The word graph me? What the heck? Graph him? Not graph meme? I'm not learning English, it's hard. What am I learning? Graph meme. Graphene. Yeah. If we look at the Hindi word written in Devanagari script, is stored as a vector of U8 values that look like this. Okay, that's 18 bytes in how computer ultimately store this data. If we look at them as Unicode scalar values, which are Rust char type, look like this. Oh, enlightened. This looks like cherries. I like cherries. So squid. How would you write a character with like a circle with so many dots? This is enlightening. Ego 難しい 難しいですね There are 6 char values here, but 4 and 6 are not letters. They're diacritics that doesn't make sense on their own. Finally, if we look at them as graphene. Do I have to learn this? Grapheme clusters. Where to get what a person would call the 4 letters that make up the Hindi word. Can I just skip this? The dotted circle is a placeholder for displaying a diacritic modifier. Wow. I wanna learn Hindu. So cool. A final reason Rust doesn't allow us to index a string to get to a character is that indexing operations are expected to always take constant time, or 1, but it isn't possible to guarantee their performance with a string, because Rust would have to walk through the contents from beginning to index to determine how many valid characters there are. I felt when Rust decides not to do something, there are always so many reasons. String slices. Okay. So we cannot access characters by index, but now we can do string slices. Why? Indexing into a string is often a bad idea because it's not clear what the return type would be. A byte value, a character, a grapheme cluster, or a string slice. Therefore, Ross asks you to be more specific if you really need to use indices to create string slices. To be more specific in your indexing and indicate that you want a string slice, rather than indexing using a single number. So I can create a range. Okay? So this will be what? What exactly? What? Those P are not the same P, those Y are not the same Y. Oh my god. Just let me print this. Come on. Print line. S. Come on, baby, come on. So this is not the index. This is bytes. This is bytes. It doesn't give me 3 part. It gives me 3. Oh, so confusing. So confusing. You should use ranges to create string slices with caution because doing so can crash your program. I'm always gonna use English. I don't wanna mess with any other language. Methods for iterating over strings. Yeah? This sound... It prints your numbers if you use bytes. Really? So if I put this is like hello young starries. What would this be? 0 to 4. It panicked because it's not at the character boundary. So how about this? So each one is like 3 bytes. I never knew it's like that. So fun. Yeah, 3 bytes per character. So cool. Strings are not so simple. To summarize, strings are complicated. Yes. Different programming languages make different choices about how to present this complexity. Rust has chosen to make the correct handling of string data the default behavior of all Rust programs, which means programmers have to put more thought in handling UTF-8 data upfront. This trade-off exposes more of the complexity of strings than is apparent in other programming languages, but it prevents you from having to handle error involving non-Ascii characters later in the development cycle. Okay, Hashmaps! Finally, my dictionaries. Chinese character takes 3 bytes because there are too many of them. Really? Is there a language that takes 4 bytes? Storing keys with associated values in Hashmaps. Okay. The last of our common collection is the Hashmap. The type Hashmap key value stores a mapping of keys of type K to the values of V. It does this via a caching function, which determines how it places these keys and values into memory. Many programming languages support this kind of data structure, but they often use a different name, such as hash, map, object, hash table, dictionary, associative array, just to name a few. Hash maps are useful when you want to look up data not by using an index, as you can with vectors, but using key that can be of any type. For example, in game, you could keep track of each team's score in a hash map, in which the key is the team name and values are the score. Given the team name, you can retrieve the score. Okay, hash map, cozy. There are Unicode points that let you stack as many diacritics as you want on top of characters. What? You put a giant characters? Thank you, Zinquest! Have a good day. Thank you for checking in. Okay, so use std. Let's create an empty hash map. So first, use it. Do we call like import? Can we call this as import? And then let mute scores equals to hashmap new. Emojis are pretty cursed too. I have no idea how many bytes is one emoji. Scores.insert key value pairs? Yeah. Key is string from blue and string from yellow 50. Now can I print line this scores? It's in the standard library, so it can be directly printed, right? Oh, okay. Like this? Why does this doesn't like that? Oh. Oh. Okay, it worked. Print my hash map. Oh yeah, note that we first need to use the hash map from collections. Of our 3 common collections, this is the one least often used, so it's not included in the features brought in scope automatically in the prelude. Hash maps also have less support from the standard library. There's no built-in macro to construct them. Okay. Just like vectors, hash maps store their data on a heap. This hash map has keys of type string and value of I32. Like vectors, hash maps are homogeneous. All the keys must have the same type and all the values must have the same type. Another way of constructing hash map is by using iterators and the collect method on a vector of tuples, where each tuple consists of key and value. Okay? The collect method gathers data into a number of collection types, including Hashmap. For example, if we had the team names and initial scores into separate vectors, team name and initial scores, we can use zip method to create an iterator of tuples where blue is paired with 10 and so forth. Then we could use the collect method to turn that iterator of tuples into a Hashmap. Okay, this looks complicated. Let's try. Emoji is 4 bytes. That's big. As they add more emoji, what if it overflows one day? Okay, we have a Hashmap. We don't have a Hashmap. We'll generate a Hashmap from the vector. Like teams equals to vec macro string from blue string from yellow. And then that initial scores equals to vec 10 and 50. Homogeneous means they store things that are all the same type, opposed to languages like Python that has heterogeneous arrays. But does Python allow dictionary with like different type of key? Python dictionary key type. Oh, it can be any type. I didn't know. Python is so dynamic. Wait, really? Different key types. A dictionary with mixed key type. Does it work? Looks like it works. Oh, squad. Python allows almost anything. Yes. Yes. And so many building stuff. Let mute scores equals to a Hashmap on the score. This is a shorthand for types, right? So we're going to zip it. Teams into iter.zip. Initial scores into iter. .collect. Code points at 8 bytes. Emojis are large. Functional territory. Oh, the zip stuff? I want to know how functional it's. Rust. So here, we make things which is a vector into an iterator, and then we zip it to another iterator of a score, and then we collect, and then it becomes Hashmap. This is like chemistry. 2 iterators became a Hashmap. Rust can infer the types, so we can use underscore. Nice. Nice. So if I print line, what was it? scores. Well, this probably will work. Initial scores. A local variable with a similar name exists. Huh? I have a typo, right? Initial... Oh. Okay, worked. It worked. Oh yeah. What? If you remove the space between the flag, you get JP? What the heck? You can do like calculations in emoji? That's so fun. That's so fun. Is there a language that's like written in emoji? So cool. Hashmaps and ownership. For types that implement the copy trait, like I32, the values are copied into Hashmap. For owned values like string, the values will be moved to Hashmap, and the Hashmap will be the owner of the values. So after being inserted, the field name and field value are not valid anymore. Okay. Accessing values in Hashmap. Get. So what's going on? We have the use. We use the Hashmap. We have a new Hashmap. We insert the key values. And then we can get the name to get the value. Emoji land? That's insane! Holy cow! If they are on the same size, the zip will result in an iterator that's as long as the shorter one. Ooh, nice. So thoughtful, zip. Emoji code? Nani? Here, score will have values. Okay, this is easy. So the return will be an option, and we can use match to handle the option if it returns now. And we can print the key values, updating the Hashmap. We can replace the old value. Wow. So let's run this. If we insert a new value, would it overwrite the old one? The answer is yes, it would. It would. That's how you update. How about upsert? What's upsert? That's upsert. This is upsert. This is upsert. Cool. Only insert a value if the key has no value. What? What? Oh. Wait, what? Hold on. Cyan, what is upsert? I think this is absurd, but this insert a value if key has no value is another thing. Welcome, Weeby. Insert will also return an option that contains the previous value if there was one. Oh, really? That's cool. I don't know insert can return stuff. So So if I do like let prev equals to this, it's going to show me a 10. Yeah, ooh, this is so cool. It gives me the previous value. So cool. It's common to check whether a particular key has a value, and if it doesn't, insert a value. There's an entry API that takes the key you want to check as parameter. The return value of the entry method is an enum code entry that represents a value that might or might not exist. Oh. So there's a type called entry enum. And it could exist, it may not exist. So if we do this program, we have a new Hashmap. We insert one record. Oh, we use or insert. The entry will so if it's okay, let entry 1 equals to this, and let entry 2 equals to this. Print entry 1, entry 2. What's gonna happen? So yellow would be 50 because there was nothing. The entry return this entry. Last one 難しい. It's a little 難しいね. Scores entry. But because we have blue will still be 10. The OR insert resends a mutable reference to the content value after it is updated. But you cannot keep around two mutable references in the same map like this. Oh, in the same map. I cannot keep two of them. So I think it takes a lot of twisting of your brain to remember what you have. Okay. So now yellow is 50. And entry 2 is 10. It's a new value. Equals to the new value. Oh. Because even though the OR insert is 50, because we have a 10, so it doesn't insert, it returns a new value, which is still the old value. Twisting of the brain is not activity. Recommended activity in daily life. It is not. It is not. Ooh. The OR insert, okay, is defined to return a mutable reference for the value of an entry key if that key exists. If that key exists, and if not, it inserts the parameter as a new value. Yes, so if it has it, return that. If it doesn't have it, return a new value. So simple, why make English so hard? This technique is much cleaner than writing logic ourselves. Yes, this is like a game changer. Like, I don't need a bunch of if statement. If, no, then, insert, else. Bad days are gone. Running the code will give us the result. Yeah, updating a value based on the old value. Oh, there's an OR insert. What does it do? It look up a key's value and then update it based on the old value. Counts how many times each word appears. So we count how many times each word appears in Hashmap, and then we split it into hello world, a wonderful word. For each word in there, our count is equals to so if it has an entry, if it has appeared before, we take the count. If it hasn't, the default value is 0, and then plus 1 to it. Rust will accept both lines. As long as I don't use it. It checks for usage. So smart. So smart. This is nice. This is like a default value. I remember there's a way to do it in Python too. Python dictionary default value. That's it? Python has a default type. Oh. The .get function can have a default value, so this OR insert is nice. It reminds me of Python very much. What is this? We store the mutable reference in the count variable, so in order to assign to that value, we must dereference count using the asterisk. The mutable reference goes out of scope at the end of the for loop, so all of the changes are safe and allowed by the boring rules. We store the mutable reference in the count variable. Oh, but it is taken by the map. This return a mutable reference to the value for the specific key. Here we store that mutable reference in the count variable. Oh, so it doesn't take the map. Ooh, my head so twisted. Hashing functions. By default, Hashmap uses a hashing function called ziphash and can provide resistance to denial of service attack involving hash tables. What is that? Ziphash. This is not the fastest hashing algorithm, but trade-off for better security. If you file your code and find that default hash function is too slow, you can switch to another function by specifying a different hasher. A hasher is a type that implements the build hasher trait. Oh, okay. We can have libraries to use new function, but what is a ziphash? Ziphash is an add or rotate XOR based family of pseudo-random functions created by Jean-Philippe Aumasson and Daniel J. Hash flooding. What is hash flooding? Hash DOS is a denial of service attack that uses hash collisions to explore the worst case runtime of a hash table lookups. Oh. Oh. They try to collide the hash and make it very slow. So zip hash. It's used. So it's difficult to find two messages with the same hash. Oh, that's so cool! I didn't know you can use hash table to denial of service. Once the keys are not unique, it lines up, so it's hard to search for them. Cool. Nice. This is fun. Okay, we're done with this chapter of collections. Summaries. We learned vectors, strings, and Hashmap. And you can do a lot of steps. And next chapter is error handling, which I'll do it next week. Almost. We're almost there. Error handling, generics, automated tasks, so many stuff to learn. It's been 3 hours of learning. Thank you guys for teaching me and staying with me. I hope you guys had fun. Learning all the new stuffs. Today we learned the collections, and then we learned. And before that, what did we learn? We learned about packages, scripts, modules. We're getting closer to build a big program from this. So exciting! Alright, the next stream is gonna be on Sunday. On Sunday, we'll be watching Hall's Moving Towel, so have the movie ready. And it's a membership only stream, so if you wanna watch the movie with me, please join the membership. And thank you guys for teaching me. Hope you guys have fun programming. Learn a lot, and see you next time. Bye bye! Thank you underscore. The entire Rust book is big and has a lot of basics. Thank you for going with all of it. You're learning Python? Good luck! Thank you, Ricky. See you next time. Alvaro, bye. Is that for Z-Show? Thank you, Arya-san. Bye bye. Bye, Yupa. Otsukare. Otsukare, minasan. Bye bye, Tommy. Bye bye.拜拜，皮喵，快睡吧，晚安，拜拜。